In commercial and industrial facilities, the type of conduit used is regulated by the National Electrical Code, often called the NEC. The NEC requires the use of rigid metal conduit, RMC, or intermediate metal conduit, IMC, in several scenarios. Firstly, where the conduit is subject to severe physical damage, such as in areas with heavy machinery or corrosive atmospheres. Secondly, where the conduit is concealed in a wet or damp location. Thirdly, where the conduit is installed underground. And fourthly, where the conduit is exposed to temperatures above 90 degrees Celsius, which is equivalent to 194 degrees Fahrenheit. Given the specifics of installing receptacles at the end of a loading dock, while the risk of severe physical damage may seem low, adherence to NEC guidelines is crucial because it is a commercial and industrial environment. For this type of installation, the most appropriate conduit type would be IMC. IMC is a rigid metal conduit that offers a balance of cost-effectiveness and good corrosion resistance. It's generally less expensive than RMC while still providing robust protection. Electrical metallic tubing is typically not recommended for commercial and industrial applications because its thinner walls make it more susceptible to damage. Beyond selecting the right conduit type, there are several other critical factors to consider when installing these receptacles. 1. Wire size and amperage. Determining the correct wire size and amperage for the receptacles is essential. This determination must be based on the load requirements of the ice cream trucks and the block heaters that will be plugged into them. It is critical to calculate the anticipated current draw to ensure the wiring can safely handle the load without overheating, which could lead to a fire. 2. Circuit protection. Providing overcurrent protection for each circuit is crucial for safety. This protection should be in the form of circuit breakers or fuses installed at the electrical panel. These devices protect the circuit from excessive current, preventing damage to equipment and reducing the risk of electrical fires. 3. Receptacle enclosures. Installing the receptacles in weatherproof enclosures is vital, especially since they are located at the end of a loading dock, which is likely exposed to the elements. These enclosures should be specifically rated for outdoor use to protect the receptacles from rain, snow, and other environmental factors, ensuring their longevity and safe operation. 4. Grounding. Ensuring proper grounding of all equipment and the conduit system is paramount for electrical safety. Grounding provides a path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. A properly grounded system also helps to reduce electrical noise and improve the performance of sensitive electronic equipment. It is always advisable to refer to local building codes and consult with an experienced electrician for specific requirements and guidance, as local regulations may have additional requirements beyond the NEC. A comprehensive understanding of these factors ensures a safe, compliant, and reliable electrical installation. The choice between different types of conduits such as RMC, IMC, and ENT depends on the specific application and environmental conditions. RMC is the heaviest and most robust conduit type, offering the highest level of protection against physical damage and corrosion. It is typically used in areas where there is a high risk of impact or where the conduit is exposed to corrosive substances. IMC is a lighter weight alternative to RMC, providing similar protection at a lower cost. It is suitable for use in most commercial and industrial applications where physical damage is a concern. ENT is the lightest and least expensive type of metal conduit. It is typically used in dry, indoor locations where there is little risk of physical damage. However, as previously stated, ENT is generally not recommended for most commercial and industrial applications due to its limited protection. The NEC specifies which type of conduit is required for different applications based on factors such as the location, environment, and potential for physical damage. Adhering to these requirements is essential for ensuring the safety and reliability of the electrical system. When selecting a conduit, it is also important to consider the size of the wires that will be run through it. The conduit must be large enough to accommodate the wires without overcrowding, which can lead to overheating and damage to the insulation. The NEC provides guidelines for determining the appropriate conduit size based on the number and size of the wires. In addition to the conduit itself, It is also important to use the correct fittings and connectors. These components must be compatible with the type of conduit being used and must be properly installed to ensure a secure and watertight connection. The NEC also specifies the types of fittings and connectors that are permitted for different applications. Branding is a critical aspect of any electrical installation, and it is especially important in commercial and industrial environments where there is a higher risk of electrical hazards. The grounding system provides a path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. The grounding system must be properly installed and maintained to ensure its effectiveness. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for connecting to ground, and the testing procedures to verify the integrity of the grounding system. Overcurrent protection is another essential safety measure for electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, protect the wiring and equipment from damage due to excessive current. These devices are designed to trip or blow when the current exceeds a predetermined level, interrupting the flow of electricity and preventing overheating and potential fires. The NEC specifies the types and sizes of overcurrent protection devices that are required for different circuits, based on the ampacity of the wires and the load requirements of the equipment. Weatherproof enclosures are essential for protecting electrical components that are exposed to the elements. These enclosures are designed to prevent water, dust, and other contaminants from entering the enclosure and damaging the electrical components. Weatherproof enclosures are available in a variety of sizes and materials to suit different applications. The NEC specifies the types of enclosures that are required for different locations and environmental conditions. When installing electrical receptacles, it is important to choose the correct type of receptacle for the application. Receptacles are available in a variety of configurations, voltages, and amperages to accommodate different types of equipment. The NEC specifies the types of receptacles that are permitted for different locations and applications. It is also important to install the receptacles at the correct height and location to ensure they are accessible and safe to use. In addition to the NEC, local building codes may also have requirements for electrical installations. These codes may be more stringent than the NEC in some areas, so it is important to be familiar with the local codes before starting any electrical work. It is also advisable to consult with an experienced electrician for specific requirements and guidance, as electrical codes and regulations can be complex and vary depending on the location. An experienced electrician can help ensure that the electrical installation is safe, compliant, and reliable. Maintaining electrical systems in commercial and industrial facilities is crucial for ensuring their continued safe and efficient operation. Regular inspections and maintenance can help identify potential problems before they lead to equipment failures or electrical hazards. Maintenance tasks may include tightening connections, cleaning components, testing grounding systems, and replacing worn or damaged parts. Proper documentation of all electrical work is also important for tracking maintenance activities and ensuring that the electrical system is properly maintained. This documentation should include wiring diagrams, equipment specifications, and records of inspections, tests, and repairs. Training personnel on proper electrical safety practices is essential for preventing accidents and injuries. Training should cover topics such as lockout/tagout procedures, personal protective equipment, and safe work practices around electrical equipment. Regular refresher training is also important to ensure that personnel stay up to date on the latest safety procedures. Energy efficiency is becoming increasingly important in commercial and industrial facilities. Implementing energy-efficient measures can help reduce energy consumption, lower operating costs, and reduce the environmental impact. Energy-efficient measures may include using LED lighting, installing energy-efficient motors, and optimizing HVAC systems. Regular energy audits can help identify areas where energy can be saved. Surge protection is another important consideration for electrical systems, especially in areas that are prone to lightning strikes or power surges. Surge protection devices can protect sensitive electronic equipment from damage caused by voltage spikes. These devices should be installed at the service entrance and at individual equipment locations. Harmonic distortion can be a problem in commercial and industrial electrical systems, especially those that serve nonlinear loads such as variable frequency drives and electronic ballasts. Harmonic distortion can cause overheating of equipment, increased energy consumption, and interference with other electrical systems. Harmonic filters can be used to reduce harmonic distortion and improve the performance of the electrical system. Power quality monitoring can help identify and diagnose power quality problems such as voltage sags, voltage swells, and harmonic distortion. Power quality monitors can be installed at various locations in the electrical system to track voltage, current, and other parameters. The data collected by these monitors can be used to identify the root causes of power quality problems and to implement corrective measures. Arc flash hazards are a serious concern in commercial and industrial electrical systems. Arc flash is a dangerous electrical explosion that can occur when there is a fault in the electrical system. Arc flash can cause severe burns, injuries, and even death. Arc flash studies can be conducted to assess the risk of arc flash hazards and to determine the appropriate personal protective equipment and safety procedures. The NEC provides guidelines for arc flash safety, including requirements for labeling equipment with arc flash hazard information and for using appropriate personal protective equipment. Electrical safety audits can help identify potential electrical hazards and to ensure that the electrical system is in compliance with safety codes and regulations. Electrical safety audits should be conducted by qualified professionals who have experience in electrical safety and code compliance. The audit should cover all aspects of the electrical system, including wiring, grounding, overcurrent protection, and equipment installation. The results of the audit should be used to develop a plan for correcting any identified hazards and for improving the overall safety of the electrical system. Electrical system upgrades may be necessary to accommodate increased loads, to improve energy efficiency, or to comply with new codes and regulations. Electrical system upgrades can be complex and require careful planning and execution. It is important to work with qualified electrical contractors who have experience in electrical system upgrades. The upgrade should be designed to meet the current and future needs of the facility and should be installed in accordance with all applicable codes and regulations. Emergency power systems are essential for maintaining critical operations during power outages. Emergency power systems typically consist of a generator, an automatic transfer switch, and a distribution system. The generator provides backup power to critical loads when the normal power supply is interrupted. The automatic transfer switch automatically switches the load from the normal power supply to the generator when a power outage occurs. The distribution system distributes the power from the generator to the critical loads. The NEC provides requirements for emergency power systems, including requirements for the size and type of generator, the location and installation of the automatic transfer switch, and the wiring and grounding of the emergency power system. Renewable energy systems, such as solar photovoltaic systems and wind turbines, are becoming increasingly popular in commercial and industrial facilities. Renewable energy systems can help reduce energy costs, reduce the environmental impact, and improve the reliability of the power supply. The NEC provides requirements for the installation of renewable energy systems, including requirements for the wiring, grounding, and overcurrent protection of the systems. Commissioning is the process of verifying that an electrical system is designed, installed, and operating in accordance with the owner's requirements. Commissioning should be performed by qualified professionals who have experience in electrical system commissioning. The commissioning process should include a review of the design documents, a visual inspection of the installation, and functional testing of the system. The results of the commissioning process should be documented and used to correct any deficiencies in the system. Decommissioning is the process of safely removing an electrical system from service. Decommissioning should be performed by qualified professionals who have experience in electrical system decommissioning. The decommissioning process should include disconnecting the power supply, removing all wiring and equipment, and properly disposing of any hazardous materials. The decommissioning process should be performed in accordance with all applicable codes and regulations. By adhering to these guidelines and best practices, commercial and industrial facilities can ensure the safety, reliability, and efficiency of their electrical systems.